All right, so let me give you a quick explanation as to how to find your equation for your regression line when they're telling you about the standard deviation and the means. So back from Algebra 1, our slope represents a rate of change, delta y in relation to delta x. It's how these two variables work together, right? So that's the basic idea about slope back from Algebra 1. So what does that mean in respect to standard deviations? So if they're telling you the standard deviation, the slope is going to be equal to, let's start at the back here, the standard deviation of y divided by the standard deviation of x, because delta y over delta x, that part should make sense back to Algebra 1. But then that fraction is going to get multiplied by the correlation coefficient, because with all of our data, the relationship to y and x is not that one-to-one relationship on the line. Our data is scatter plot, right? So the r tells us how strong that relationship is, and that's why we're multiplying by r. In an Algebra 1 setting, if you just have the line, that r would just be the number 1. Okay. All right, so that's the slope part. Now, if they tell you the mean of the x values and the mean of the y values, so remember, when a bar is on top, that means mean. So this would be the mean of the x values and the mean of the y values. So, little fact, the point x bar, y bar is always a point on the regression line. So the average of the means and the average of the y's, that ordered pair is always on the regression line. So that means that is a particular x and y value that satisfies the equation. So if my regression equation, I can plug in those specific x and y values. So y bar equals b plus m times x bar. If I'm using m and b as we do in Algebra 1, m is our slope, b is our y-intercept. So that means if you know the means and you know the slope, you can plug in y bar, you can plug in m, you can plug in x bar, and then you can use those to solve for b, and then you'll be able to write your regression line.